Hey everyone, today we're going to cover the OAuth 2 redirect flow with authorization code flow with PKCE. This is an OAuth 2 standard created by the OAuth working group, and a lot of IDPs out there implementing this approach, and you probably want to in your application as well. So I have this working for both mobile and web application, and we'll go over the pieces in detail here. So the first piece here is my FlutterFlow application, in which I'll go over a lot of the configuration, but I want to start with some high-level architecture and how the OAuth 2 flow works for the authorization code flow with PKCE. And to do this, I'll actually pull up a sample application as well. This one's running on an Android emulator, and essentially the user is going to come to the application, they're going to click login. It's going to redirect out to that identity provider in which they're going to provide their credentials. In this case, I'm leveraging Okta. And I'm going to go ahead, and what's happened behind the scenes is I've created a code challenge, and I've created a state variable that I'm going to send as parameters to my Okta tenant. And when we go through the code walkthrough section, we'll have a lot more in-depth discussion about each one of those pieces. So I've been sent back to authenticate and consent, which is what I did there. And then it's sending me back to the Okta tenant. The Okta tenant is then going to create an authorization code, and we're going to set up something called a callback URL on Okta's side. So when we set up our application configuration in Okta, we'll actually set one up for both mobile and web. And we'll go over that in detail as well. We'll get to the architecture first. So with that callback URL that we set up on that side, it's going to redirect us back to the application. In this case, it might be something like com.mycompany.octademo:/callback. So it's that callback route. And here we're going to go ahead and we're going to send the authorization code back to the Okta tenant along with the code verifier so that it can verify the code challenge that we sent to it originally. And this is a request made to the /token endpoint. And if I didn't specify before, this was the /authorized to get to the Auth0 tenant initially when I clicked that login button. Here, the Okta tenant is going to go ahead and validate that code challenge that we originally sent it with the code verifier provided in the second step here, or in the seventh step. And if all checks out, we're going to go ahead and send that ID and the access token back to the application, in this case, FlutterFlow. Users then have that access token and can make requests to our backend resources or APIs that might be protected by certain scopes or permissions on that access token. So a couple of reasons why authorization code flow with PKCE was originally implemented. This is really to stop things like man-in-the-middle attacks. If someone's watching our network traffic and we've already sent the code over and there's no additional code verification, step right here, number 8. Basically, if I sent that authorization code back and someone were to intercept that, they could exchange that code for an access token and an ID token. So a malicious actor could get in, and we could prevent this by implementing that PKCE step by sending the code and the code verifier so that we have a little bit of back and forth communication between our client application and the authorization server, in this case, Okta. Other threats to this could be redirect URI manipulation. So if someone set up a redirect URI and on Okta's side, you set back a callback URL that went to a malicious redirect URI or use something like a wildcard, you could be sending that authorization code to the wrong place, but we know that they didn't have the original code verifier that initiated that request. Other pieces could be something like a cross-site scripting attack in a single page application or a Flutter web application. Someone could inject malicious scripts in order to capture that authorization code from the redirect URL where it's calling back to. And lastly, something like a malicious browser extension that you might have installed that's snooping on your activity. The authorization code flow with PKCE helps mitigate a lot of these problems in modern web development. So reeling it back, mobile applications and single page applications are what's known as public clients, right? I cannot store a client secret on my mobile app or my single page application because technically that's viewable to anyone that can see in my browser tab. So my application settings, if I want to look at the code, I'm able to actually sniff that out uh, in the browser or on a mobile device. I'm actually each person that's downloading that mobile app is downloading the source code, and somewhere in there, compiled in all of that machine code, there's actually a secret that's laying around. So if someone's really savvy, they can get a hold of that and use it. So um, when we're using authorization code flow with PKCE, we're only sending over the client ID to make this authorized request. Perfect. Let's go into a couple of other steps here now. So I'm going to move into my Okta environment first so that I can show how we set this up end to end. And the first thing that we're going to need to do is come to the admin panel and go to applications. Here you can create a new app integration, and we want to set up an OIDC client, and we're going to need to set one up for both single page and native applications. So go ahead and choose one of those. I'll start with native application. I'm going to go to the one I already have set up, but I'll touch on all the pieces that go into it. So under my Okta demo here, once we've created that, we're going to have a client ID associated with what's going to be my mobile application within Okta. I'm going to require PKCE. And scrolling down, really the only other setup step that's required is setting up this login. So let me come back up and hit edit here. And it's going to ask you for your company's URL scheme. So in this case, it's com.mycompany.octademo. That's my project name. And you'll be able to find this in the Android manifest file or on the iOS side, you should be able to find this as the product bundle identifier. Sign out URL, where do we want to send them when we hit that log out? We'll just send them back to the root of the application. So that's the setup for the mobile. And we'll jump over to the single page application for that second one. And we're just going to have a client ID. We're going to go ahead and require PKCE. We'll scroll down. And I'm going to set something up for http://localhost 8080/callback. And then the sign out will just be the root again. So relatively easy setup. One last thing I would recommend is I would just enable access to everybody. So if you enable this, make sure that the user that you're attempting to sign in with is assigned to this application. I believe Federation Broker Mode actually assigns everybody, but in the case that you're failing to sign in and you're getting to that login, that might be the issue. I also disabled any multi-factor just for purposes of the demo, but that's the nice thing about using authorization code flow with PKCE is that it sends you to that authentication provider or server. And in this case, it's Okta, and I can set up whatever security I want on my application. I don't have to implement that application side. So let's go back to the FlutterFlow environment. Let me move this off my screen. And the first thing that I'm going to touch on is setting up an app configuration. This will make it easy for us to switch these values around, our configuration values, as we move between development and production. And there's a couple of pieces that I'm going to need. I'm going to need an API base URL. So this is going to be something like mattmckelvey.okta.com. And we'll go over what that actually is once we get to the code. We're going to get a mobile client ID. So when I created the mobile application within FlutterFlow, we're going to copy the client ID. This is the web that I created, but just grab it for the mobile. We're going to need the mobile redirect URI. So in that case, it was something like com.mycompany.octademo:/callback. And then we're going to need the web client ID. So that second application we created and the callback for that as well. And we'll set that as the redirect URI. You don't need to set any of these values. We'll have a configuration file that does this on the load. And then a mobile callback scheme. So that's just going to be com.mycompany.octademo. Perfect. Lastly, we're going to take app state here, and I'm going to create an app config. And essentially what that looks like is I would create app config, and I would go ahead and choose a data type. and I would select that app configuration data type that we just created. You don't need to persist this, but you can if you need to. It should run on when the application loads itself. So that's how I have it set up. I have run this both with and without the persisted values. I would recommend probably turning it off. Perfect. Now let's come down to the custom code. And the first one we're going to look at is loading that app config, all those values that we just set up. So we're going to create a app configuration struct to assign values to each one of those in our app state. And we're going to need that mobile client ID that we got from our Okta tenant. We're going to need the callback URL or the redirect. We're going to need the callback scheme, which I have set up here. And then for web, we're going to need the client ID and the callback. Now I've set default values so that when I spin this up on a local emulator and I run it on port 8080, it's going to call back to this. So we set that up on Okta's side. It's another security step to say, hey, I'm only allowing this application to call back to these specific URLs that I've defined. Mobile is going to be a little bit different, but we'll cover that piece as well. So these production web redirect URLs, I set these in here. One of my colleagues set up a really good program so that when I'm running things locally, I can spin up a environment config file. That way I'm not putting any sensitive information inside of my FlutterFlow environment, and I can exclude it from source control. But if there's a production environment Okta that you're working with, and you want to put those values into that config file on your local VS Code, you can certainly do that, and it'll take to those instead of the default values. Now we're going to go ahead and we're going to move this load app config from environment to our main file. So just pop down into this main.dart file, and off here on the right hand side, you should be able to select a final action, and you should be able to choose one of those actions. So go ahead and select that load app config from file. So that's just after we've initialized our FlutterFlow app state. We'll be able to load that config from environment. So when the app starts and main runs, it'll take the default values unless you provided a config file that has these strings in it, like this prod base URL. Then you can switch between environments and keep that out of FlutterFlow entirely. Perfect. So let's go back and walk through the flow really quickly. So we're going to go through mobile first, and then we'll touch on web, because web's a little bit different. And I'm just going to have a simple login button. So I'll go ahead and click this actions panel, and we're going to call a function that we create called initiate auth. And this is constructing that authorized URL to take us to our identity provider with all the pieces and parameters that we need. So let's go ahead and jump into that initiate auth function, and let's start walking through this together. So there's a couple of pieces that are needed. The first one is we're going to need to generate a code verifier. And I'm going to scroll down, but we're also going to need to generate state. I'll come back to this in just a second. Let's scroll down. I've just created these functions down below. You could create them as separate actions. I've decided to create them directly in here. So generating a code verifier is going to take random.secure, and we're going to generate a list of 32 characters between 0 and 256. We're going to base URL encode those values, and I'm just replacing the equal signs. I'm not so sure that you need this step, but in the case that the URL is trying to set up a query key value pair, I've excluded that. State is going to be exactly the same, except I'm just generating 16 characters. And the OAuth 2 code flow with PKCE, or authorization code flow with PKCE, is going to detail that we're going to need to generate a code challenge with that code verifier. I've set up a separate function for the generate code challenge, and I'm passing it the code verifier. So in the initial authorize request, we'll send this code challenge, and then we'll send the code verifier when we request the token later on. So I'm going to UTF-8 encode the code verifier, and then I'm going to use the crypto package to do a SHA-256 encoding of those bytes or encryption of those bytes. And then to make it URL safe, as I send it over to the authorized URL, I'm going to encode it with base 64 URL. So the arguments that you need for this function are a code verifier, which is just a string that we're randomly generating from the initiate auth, and the crypto package. So make sure that you bring those in. And then we want to return a string, which is going to be the code challenge itself. I brought in these two packages just to point out and be clear what I'm using here. Let's go back to the initiate auth. And now that I've mentioned some of those packages, I want to come off and point out some of the packages that I'm using. For mobile, I'm using Flutter Web Auth 2. This is a open source package on pub.dev. And I'll go to that now. And this abstracts a lot of the complexity away from us when it comes to using Google Chrome tabs and the Safari View controller on iOS for navigating with a headless browser within our application. So I'll scroll down here and we'll ignore this for now. There's a little bit of additional setup. So for iOS, or sorry, we'll start with Android. For Android, in our manifest file, our Android manifest.xml, we're going to want to add this information. And I'll show what mine looks like in my project as well. For iOS, there is a configuration step, I believe, for running on production. But if you're testing things out locally, you actually don't need to do anything. And that's just editing something in what I believe is the info.plist file. Maybe they did put that underneath. Nope, I'm not seeing it. Okay, let's go back and walk through this. Universal HTML, this package is being brought in because the regular HTML package sometimes throws errors when you run on mobile. So if you have a cross-platform use case, we might want to use Universal HTML, which provides all of the, pretty much all of the same functions or functionality as the regular HTML file. Up here, I've brought in Foundation, that Flutter Web Auth 2.dart. I've brought in math, convert, and I've brought in the universal HTML file as just HTML, and I'll show when we get to the website why that is. And I'm bringing in Flutter Secure Storage, which is already a package that FlutterFlow utilizes. That's why I did not need to bring it in here. We're going to make the return type of this JSON as well, because we're going to send something back to our action chain when I click that login button on the FlutterFlow home screen or login screen. Scrolling down, let's start with the mobile first. We need a client ID and a redirect URI. And now we're composing the authorization endpoint. So I'm going to skip this, but if it's web, we're going to use these two values, which I've set up in my app config. And if it's mobile, we're going to go ahead and use the FlutterFlow app state mobile client ID and the mobile redirect URL. And to show where those are again, when we're loading that in, we're setting that app state variable to each one of these values that we have set up here. Let's go back to initiate auth. And we're going to be taking this because this is not web in this case. I'm going to grab the base URL of my tenant. Like I said, this is something like https://mattmckelvey.okta.com. And then I'm grabbing the trailing endpoint to call the authorization endpoint. So OAuth2 default v1 authorize. And I can drop the details for the docs in the comments. And one important side piece to note with Okta is that this is the organizational authorization server. So if you are using API access management, which is a SKU that you can purchase at Okta to push out custom authorization servers, then you would have a different endpoint than this, and I would follow the doc reference in order to achieve what you're looking for. The response type is going to be code, and then in the scope, I just want OpenID, profile, and email. Now I'm constructing that URL. So I want my authorization endpoint, which I've constructed here, /authorize, and then the queries are going to be response type, which I've defined as code, client ID, which I'm defining from my app state variable, redirect URI, in this case, these two are for mobile, the code challenge, which I generated above and called that other action for. And I'm telling Okta that the code challenge method is SHA-256. I'm passing the scope along, and then the original state that I generated to up here. We'll ignore the Tase web for now, and we'll move into the mobile side of things. And I'm going to await a result. And this is going to be from that Flutter Web Auth 2 package. This is going to open the Google Chrome tabs, or it will open, let me pull up my emulator here. In this case, the Safari View Controller. So this is the Safari View Controller. I can go ahead and click Next. And go ahead and log into that. Get taken to there. Okay, that result is going to return the code, and it's going to return state that I originally sent, or that the code that Okta is sending back to me, and the state that I generated originally, to make sure that we're not receiving some malicious code and it's not the same state. So we're securing that communication line back from the callback. We're going to parse that result. We're going to grab the query parameters for state and code, and we're just going to make sure that the state is the same and that the code sent back isn't null. And then we're going to exchange that code for a token. This is where this is going to end. I'm going to come back to here and return it, and that should be my access token, my ID token, optionally a refresh token. We didn't cover that step, but if you're using mobile and you want your users to stay logged in, you could certainly add an offline access scope to the scopes here, and there's probably a configuration step within Okta to, let me go to my Okta demo here, to supply a refresh token if I want to choose that grant type as well. Okay. So let's go to the exchange code for token, and I'll show you where we are in the flow now. We've generated the code challenge and the state. We sent it to the authorize endpoint. Okta is now sending back to our redirect URI or callback. We authenticated and consented. I apologize. We authenticate and consent, and then Okta is taking the authorization code and sending it back to our application. And now we have the code in the application, and we want to exchange the code for a token. We're going to exchange it with the code verifier as well, so it can do its last step to solidify the PKCE step there, the proof key code exchange. So exchange code for token is another function that we're going to call, or action rather, and we'll start at the top. The packages that I've brought in are DO. This is probably, if you're a web developer, the equivalent of what Axios is to fetch. This is what DO is, the regular HTTP package. I preferred to use it in this context, so that's what I'm using here. I'm taking the code and the code verifier as arguments that I'm going to use to send to the token endpoint. And I'm going to return JSON value. So we're going to grab the base URL, and now we're constructing our token endpoint, which is the base URL OAuth to default v1 token. This is what it would look like. That may vary if you have a custom authorization server in Okta, but we won't go over that step now. It's not web, it's mobile. So we're going to use the same thing. We're going to get the client ID and the mobile redirect URI. And we're going to come down here and we're going to make a post request. So instead of a GET request this time, we're making a post request to the token endpoint, and the grant type is authorization code. The code that we retrieved from Okta, they sent back to us, the redirect URI, the client ID of, in this case, the mobile application, and the code verifier. And that code verifier we never sent in step one to the authorized call. We sent the code challenge, and we're going to send the verifier now so that they can verify the code on their side. Make sure in the headers you put your content type to be application XWWW form URL encoded, and you want to accept application.json. The response should yield a 200 if we got our tokens back successfully. You can strip this down. I left some of this in here. If you want to take response.data and see what the ID token, the access token look like, you can print those out. You could even store these directly in app state in this function. I've decided to return them back up the chain, so we'll go over that now. I'm adding the status code of 200 to the JSON object that I'm going to return, just so that I can pass that into my FlutterFlow application and make some decisions based on the status code retrieved. If there was an error with this flow, I'm going to put the status code in here. Maybe I forgot something or I'm unauthorized. I'll get that status code back and I can make decisions at the UI layer on what I want to do. Or if there was an issue with DO in general and the overall response, or we got a server error, I'm just putting a 500 as the status code and returning something went wrong. So this is going to return our ID token and our access token expiration time back to our initiate auth, which returns the Okta response. What that looks like in that login flow is I'm checking for the code expression. If the status code equals 200, then I want to go down this chain. If it doesn't equal 200, maybe I want to navigate them back to the login page or show an error message in the snack bar. I have options there. I just put this as the success criteria here. I've created a custom action to decode the tokens that are coming in. So the access token and the ID token. And we can take a look at that custom action that I created as well. In this action, we're going to need to bring in Jot Decoder, another open source package on pubdev. We're passing it the token, and we're going to return a JSON value. So that'll give us all the scopes and claims inside that token. Things like their email, their UID, subclaim, expiration. Any custom claims that we might have put on the access token might get passed through here as well. We can decode that and just return that decoded token. The same is going to go for the ID token, and I'm just labeling these as decoded IDT and decoded AT. I'm going to update my app state. I've created an app state variable for access token that I'm going to persist and use FlutterFlow secure storage to save that encrypted on the device. I'm also going to just set display name for my demo purposes. Now, lastly, we have our auth login. We are using custom authentication, so we can set our authentication token as the ID token. In this case, I never passed an offline access scope, so I don't have a refresh token. You could take the token expiry time. You'll basically get an integer value back for that expiration if you decoded that ID token, but you could drop that into here. And the user ID I'm pulling out of the decoded access token. In this case, it is labeled as UID. I believe it is on the ID token as sub as well. And we can probably even verify that here. Yeah, the sub value in the ID token is that user's ID. Perfect. Then that will navigate us, automatically to our logged in page, which is our home page, and brings us here where I have the display name and the two tokens. I can use the decode button to essentially reveal, update the page state to show the JSON representation or the string representation of the encoded token. So that walks through the entire mobile flow. Now, I want to take a step back and kind of go through the same thing, but for web and these cross-platform development use cases. There's a lot of different ways to do this. The way that I have it set up, and we're going to go through this a little bit more quickly because we know a lot of the pieces. We're still going to generate the code verifier, the code challenge, and the state. We're going to take the web client ID, web redirect URI, which would be that localhost 8080. And we're going to construct our authorized endpoint with the web configurations instead. Now, this is where we use that universal HTML package, and we can use Flutter Secure Storage to write a key. So this OAuth 2 state, we can write the state value locally in our browser and the code verifier locally in our browser. I'm going to pull open the web here. We can actually inspect this. Well, can't drag that corner. And we'll go off to the application tab and we'll go ahead and click log into Okta. Oops. We can see we're navigated back to a callback page really quickly and then taken to our home landing page. And the step here that I was showing of writing that into storage, as we can see it in our local host under our local storage, we're just writing the state locally and the code verifier locally so that we can verify those values as they come back. We're going to take the redirect or the authorization URL, and that takes us to Okta in this case. That's what we've constructed up here. So all I'm doing is taking the window, location, href, the current window that we're in, and I can back out and do that, and constructing that URL for us to send over. Okta is then going to call back to localhost 8080, that callback URL, and I've set up a callback page. So if we're running this locally on port 8080, this is our callback route that I've defined here as just a regular callback page. There are other ways to handle this. If you want to set up an API endpoint to call back to, you could do that and then have it send it back to your application. I've been thinking of a couple of different ways to put Firebase in the mix, but I want to keep this as FlutterFlow focused as possible. On the page load in this callback, so if I click on this overarching page and I go to the actions and open this, so we can do this on page load, we're going to check if the user's not logged in. We're going to go ahead and handle the auth web callback. This is our last custom function. And I'll go ahead and take a look at that now. And what that looks like is we're going to have that Flutter secure storage. We want to bring the universal HTML package into here. We're going to check those query params that we set, the code and the state, if you remember from previously, or sorry, the stored state and the code verifier. We're going to check that those are the same as when we made the initial request. And we now retrieve the code and the state from the callback URL. So I'm going to try and pin this really quickly. And bear with me here. You might have to pause the video in order to see it. But I'm calling back. You can see the callback. The code is equal to this, and the state is equal to that. Okay. And I'm grabbing those values, and then I'm going to exchange the code for the token. That was that other method that we implemented, and it's going to be the exact same flow. And we're going to pass the code and the code verifier that was stored in our local storage. I'll go back to that exchange code for token just so we can see it one more time. In this case, we're going down the web path. So we're passing our web client ID or web redirect URI. And then we're making the post to the token endpoint with the different redirect URI. In this case, it was localhost 8080 / callback, and the code that was passed to that callback page. So now we're passing it into this. It's the same exact function, and we're going to go through the same exact steps, except the only difference here is that we did a on-page load on this callback. If the user was already logged in, we could just navigate them to the home page. And then if we got an error back, so it wasn't a 200 status code, we could send them back to the login. We're going to do the same thing, decode the access token, the ID token, update app state with the access token of that name, as I did before. We're going to authenticate with our custom authentication, save the ID token down, maybe the expiration from the ID token, and save the user's UID. And then we'll just navigate to the home page. The reason I didn't do automatic navigation here is because I wanted the replace route. Let's see if I go back here, it takes us back to the Okta page instead of that callback page. A little bit cleaner in case the user does that. Perfect. So I'll close this. If for whatever reason they got stuck on this page, if the page didn't load or there's some kind of other error action, I did put an action here to just check if the user's logged in. We can navigate to the home page or navigate to the login. So that's covering the authorization code flow with PKCE using Okta. One last thing that I forgot, apologies, is that if you are utilizing an Android device, that Flutter Web Auth 2 package does require you to navigate up to the app source Android manifest.xml, and it requires you to put in this activity. So you can find the main activity under application, and then create another activity after that main activity for the Flutter 2 Web Auth 2 callback activity. And make sure to specify your URI scheme. In this case, mine was com.mycompany.octademo. For iOS, you can put this in the info.p list as well. Not this exact thing, but let me jump into that real quick. Where is it? It's under runner. Info.p list. And then under this bundle URL scheme, you could drop this into here. This is not required for the demo purposes. Oops, we're going to drop a URL scheme string. But you could put a string com.mycompany.octademo as well. Awesome. The only other piece that you might want access to is please use the FlutterFlow CLI, pull the code down locally and test it there. If you're trying to run this in test mode, you'll probably run into issues with the redirect URIs not being correct. So pull it down locally, and mobile should work just fine. If you've added those values to the Android.manifest, or if you're running on iOS, there's no additional setup. And if you're running on web, the one piece that I will call out is, let me close this out. Please run it with Flutter run -d Chrome --web port equal to 8080. That'll run it locally on 8080 so that when our callback goes back to that 8080/callback route, it grabs it successfully. If you run it on a different port, that won't exist. Awesome. Thanks, everyone. Take care. Bye.